First, let us see why do we require Hadoop? What is the importance of the Hadoop to the industry? The second one, Hadoop origin, who developed Hadoop and who is contributing on releasing different latest releases. Then, to learn Hadoop, what is a prerequisite? What are the prerequisites? Then, who can learn Hadoop and become an expert? Then finally, Hadoop job market. So, what kind of jobs available in the industry? Completely Hadoop job market. Then the last one. So why you had to choose Lara to learn big data Hadoop? Let us have one by one. First one, why Hadoop? There are a lot of different types of use cases which are telling Hadoop is 100% required. Different types of use cases are there where Hadoop only can address the type of use cases. First, let us see first type of the use case. This use case is to handle big data. In order to handle big data, Hadoop only the solution. There is no other solution. There are no other softwares to handle big data. What is a big data? Big data is a huge volume of unstructured data. Big data is a huge volume of unstructured data. Data, it can be structured, it can be semi-structured, it can be fully unstructured. Wherever data is semi-structured and unstructured, that cannot be handled through RDBMS, we required Hadoop type of softwares. Data can be structured, it can be semi-structured, it can be fully unstructured. In case of semi-structured and unstructured, we should require Hadoop type of software. Let us see how data will be in case of structured, in case of unstructured. Let us see structured data. It's something like a rows and columns. In every row, fixed number of columns, fully structured. So everybody might be knowing structured data. So all RDBMS supporting structured data. From 1970 itself, industry using RDBMS to address the structured data. In order to handle structured data, RDBMS databases using by the industry from 1970 itself. Then come to unstructured data. There is no relationship between first line and second line. There is no relationship between first sentence and the second sentence. It is fully unstructured. So data, it is not something like a fully structured. Unstructured data. Unstructured data. No relationship between first line and second line. First row and second row. First sentence and second sentence. First paragraph and second paragraph. First document and second document. It's fully unstructured. Wherever unstructured data and semi-structured data is there and all, you have to go for Hadoop. Big data is a huge volume of either unstructured or semi-structured. If it is fully structured, then you can use RDBMS also. If it is unstructured or semi-structured, it is called as a big data. To handle big data, you have to use Hadoop. What are the sources of the big data? What are the different sources of big data? where big data is generating. Where big data is generating. All log files are generating unstructured huge volume of data. Unstructured huge volume of data, that is a big data, log files. Every application will be having minimum one log file. Every server will be having minimum one log file. The data from the log files is a fully unstructured, To analyze log files data, we should require Hadoop type of software. To analyze data from the log files, huge log files, every day there will be minimum one log file from every application and even from every server. To analyze log data, we require a Hadoop type of software. Then social media sites, whatever generating data every day. Social media sites like Facebook, Twitter, all social media sites every day, some thousands together, TB of the data, terabytes of the data uploading from different parts of the world. To analyze that data, we should require Hadoop type of software. Whatever data getting into social media sites, that complete data is a unstructured data. To handle that unstructured data, we should require Hadoop type of software. Then books, mail documents and any other documents, completely unstructured. There is no relationship between from one book to another book. There is no relationship between from one mail to another mail, even any documents also. Nowadays in the internet, all books are available. Several mails, several different types of documents will be available in the internet. In order to analyze data which is available in the books, mails and documents, we should require a Hadoop type of software. This is one of the use case. This use case tells like handling big data by the Hadoop. Come to the second use case. So where Hadoop only has to use. Second type of use case, warm. Write once and read many times. Write once and read many times. The best example is YouTube. Whatever audio file and video file we are uploading to YouTube, we are uploading one time, but we are accessing several times. We are accessing several times. Hadoop internal structure is very efficient to handle write once and read many times. Hadoop internal structure, it supports for providing efficient warm, write once and read many times. So wherever writing a document one time and reading again and again, in that scenario Hadoop is the best. It gives a more performance while reading. We are not concentrating on writing performance. We are concentrating on reading performance. Why? Because we are writing only one time. We are not writing again and again, but we are reading again and again. Hadoop gives more performance in case of reading. So throughput means amount of the work in a particular unit of time. Amount of the work in a particular unit of time. Read throughput is more if you are using Hadoop. Read throughput is more if you are using Hadoop. More amount of data it can read in a unit of time. Forget about the writing, consider reading. Hadoop internal structure, it supports for effective reading. We can read any big file very quickly. Come to the third type of the use case. Third type of use case is 100% availability. No fault tolerance, 100% fault tolerance. Whatever file we are storing in the Hadoop system, that file will be 100% available. No question of going that file into unavailable. At any moment we can access that file. 100% availability. Achieving 100% fault tolerance. No question of going our file into unavailable. At any time, at any moment, from anywhere, we can access that file and we can use that file. System crashes or systems going into down. This will not be affecting to the Hadoop. Hadoop internal structure, they addressed system crashing and systems are going into the down. Even though some of the systems are crashing, still your file will be available. You can access your file at any time from any location. This is the third type of use case. Then the fourth use case. Very less cost setup while storing huge data. Cost setup is very less in case of both hardware and also software. Hadoop is free to use. No need of buying a software. You need to spend cost only for the hardware. And that too, hardware cost also very negligible compared to other ways of storing huge data. There are a lot of other ways to store huge data, but more hardware cost is required. If you choose Hadoop, very less hardware cost setup and zero software cost setup. 0% software cost. Hadoop is absolutely free. Even for commercial usage also, Hadoop is absolutely free. And very less negligible hardware cost setup. While storing huge data, there are a lot of solutions, but in all other solutions, lot of hardware cost setup is required. But here, very less negligible hardware cost setup and zero software cost. Then come to the next use case. 100% scalability. This is very, very important use case. While storing data in the Hadoop system, we don't require to consider about scalability. Scalability is an internal feature of the Hadoop. Developer doesn't require to concentrate on writing scalable programs. Whatever program he is developing for small data, same program will be holds good for the huge data also. Whenever data is increasing exponentially, program doesn't require to modify. Whatever programs we are developing in the Hadoop, all the programs are 100% scalable. Programmer doesn't require to concentrate on developing scalable programs. Every program by default it's scalable. It can able to handle small data and even huge data. No logic is required to modify whenever data is exponentially increasing. So let us consider, we developed one solution to handle 100 TB of the data Same solution will be holds good even for 1000 TB of the data or even 1 lakh TB of the data. Your solution doesn't require to change. Not only solution, whatever setup we are incorporating for handling 100 TB of the data, same setup will be holds good for 1 lakh TB of the data. We don't require to change any setup or any program logic. Scalability issue, it is an internal part of the Hadoop. In the industry, no software is providing 100% scalability. Only Hadoop is providing 100% scalability. If you are developing a program for 100 elements, same program will be holds good even for 1 lakh elements also. We don't require to scale our program for 1 lakh elements. Automatically, whatever program we developed for 100 elements, same program will be scaling to 1 lakh elements also. It is one of the very best use case where Hadoop is used. Then, the last use case why we had to go for Hadoop. Very simple programming model. We don't require any experts to develop programs while storing the data in the Hadoop. Even beginner also can develop the programs to analyze the data which is stored in the Hadoop. Very simple programming model. No complication at all. Doesn't require any kind of expertization while developing programs to analyze the data which is stored in the Hadoop. So these 6 use cases are explaining why we required a Hadoop. Now let us see Hadoop origin. Hadoop origin. In 2003, Google released one white paper. That white paper, GFS, Google File System. GFS stands for Google File System. In 2003, one white paper released by Google. That white paper is called as a Google File System. This Google File System is clearly explaining how we can store huge unstructured volume of the data. Google is using GFS, Google File System, to store a very huge unstructured volume of the data. Through this white paper, industry got to know how we can store a huge volume of unstructured data. This is one of the base for Hadoop origin. A year after, in 2004, Google released one more white paper. That white paper is a MapReduce. This white paper explains how we can process huge volume of the data after storing in the GFS. After storing huge volume of unstructured data in the GFS, how we can process the data, how we can analyze the data, what kind of programs required to analyze huge volume of unstructured data which is stored in the GFS. MapReduce is a programming model. What kind of programming model we have to use to analyze a huge volume of unstructured data? This is also explained by Google in 2004 through one of the white paper. That white paper is a MapReduce. These two white papers are based to Hadoop origin. 2003 GFS, 2004 MapReduce. By making use of these two white papers, in 2005 in 2005, two developers of Yahoo company, they developed a software called Hadoop. In 2005, two developers of Yahoo company developed Hadoop. So Hadoop, it's a combination of HDFS and MapReduce. HDFS stands for Hadoop Distributed File System, very similar to GFS. Based on GFS, they developed HDFS, Hadoop Distributed File System. By making use of two white papers from Google, Hadoop came into the picture. Hadoop developed by initially Yahoo developers. Two developers are involved in the Hadoop. The name of the Hadoop, it is a toy elephant name of one of the developer's son. Yahoo, two developers involved in the development of Hadoop. Between these two developers, one developer's son, toy elephant name is a Hadoop. They have chosen the same name for their software. Whatever software they developed based on GFS and MapReduce, for that software they are given a name as a Hadoop. Hadoop is a name of the toy elephant of one of the son of the Hadoop developers. So between two developers, one developer's son, toy elephant name. In 2005. Initially, in 2005, Yahoo used Hadoop software for their internal applications. In 2005, only Yahoo was using for their internal applications. After proving successfully a year after, in 2006. In 2006, it is donated to Apache. Yahoo donated to Hadoop is donated to Apache. Apache is one of the open source community. Yahoo donated Hadoop to Apache in 2006. From 2006 onwards, Apache only taking responsibility to enhance the Hadoop. For all further releases, Apache only taking care of releasing further releases of the Hadoop. Now Hadoop is releasing from the Apache only. This is about origin of the Hadoop. What are the prerequisites to learn Hadoop? To learn Hadoop, what are the prerequisites? Any programming language basics, not even advanced. Any programming language basics. Hadoop is supporting several programming languages, widely using languages C, C++ and Java. Among these three also very widely using is Java. Among these three, among these C, C++ and Java, very widely using programming language in Hadoop is Java. Hadoop is completely developed in Java. That is why better to use Java programming language while developing programs in the Hadoop. Debugging will be very simple if you are developing programs in Java, just because of the entire Hadoop has been developed in Java itself, preferably Java, and that is very basics of core Java. You don't require any advanced concepts of core Java itself, but preferably every topic of the core Java, but in every topic only basics are required, not like all the concepts of a particular topic. But the main topics you required, basics of programming language like all hoops concepts, then exception handling, and generics. Mainly OOPS concepts from the core Java, then exception handling, then generics. These three are highly sufficient. We don't require ins and outs of inner classes, ins and outs of threading, ins and outs of collection API, but you required just basics. Then basics of Unix commands. Only basics on Unix commands. Something like a very frequently using commands of Unix are highly sufficient. You don't require either shell scripting or any advanced commands of the Unix. Basic commands like creating a directory, copying a directory, something like a moving a directory, deleting a directory. You should know some basics of handling Unix file system, but is highly sufficient. Then the third one, basics on SQL. So here also very basics, you don't require any advanced concepts of SQL. Only basics like creating a table, inserting a row, updating a row, deleting a row, and reading a row. Something like a basic operations of SQL, those are highly sufficient. Even though you don't know anything about Unix and SQL, still you can learn learn Hadoop very properly. Whatever commands you require from the Unix, whatever commands you require from the SQL, that you can learn and then you can start Hadoop. But programming language basics are mandatory. Any programming language basics. If you know basics of C++, that is very sufficient to develop program in Java itself. You don't require to learn separately core Java if you know already C++ basics. That is highly sufficient. Then, who can learn Hadoop? Any graduate can learn Hadoop. Doesn't require compulsory a technical student or maybe a master graduate, even ordinary graduate also, like BSc people also can able to learn Hadoop. So here we don't require students like scoring 80% or 90%. Even below average student also can learn Hadoop and easily he can become an expert. Why? Because Hadoop required very simple programming model and some of the commands related administration. So this any graduate can understand, can implement a solution for the customer by using Hadoop. Hadoop job market. Every MNC hiring Hadoop developers. Every MNC hiring Hadoop developers. Whatever projects developing by big companies, in all those projects, some or other portion of the unstructured data will be. To handle that unstructured data, Hadoop developers are required. Nowadays, in all big companies, from every project, a Hadoop requirement is there. Big projects are having some or other unstructured data. To handle that, we require Hadoop developers. In every project of the big companies, a Hadoop requirement is there. Nowadays, even small companies also hiring the people from the Hadoop and they are deputing in the MNC companies. But small projects doesn't require a Hadoop. In small projects, we will be ignoring unstructured data. If at all you are concentrating unstructured data in the small projects, there also Hadoop requirement will be. Small customers might not be focusing on unstructured data. That is why might not be required for the small projects and small companies. If it is a big company, almost big projects only, then that big projects, they might be having some importance on handling unstructured data also. That is why Hadoop is required for all big projects. Nowadays, small companies are hiring and deputing in the big companies. So maybe in another 5 to 6 years, every software engineer should know Hadoop. Why? Because in coming after 5 to 6 years, even small customers also, small projects also, small customers, they are also thinking about automating unstructured data. If at all, they are also considering importance of the unstructured data, then requirement will be in every project. So in down the line, every software engineer should know at least some basics of the Hadoop. Nowadays, small companies, whatever projects they are handling, they are telling to the customers like there is no solution for unstructured data. That is the reason they are not using Hadoop. So in down the line, customers, they themselves will come to know like there is a solution for handling unstructured data. Then customers will be forcing to the companies to use some automation to handle unstructured data. So small companies also has to use Hadoop in down the line. So in the Hadoop, majorly two types of the jobs you can find. One is a Hadoop developer, second one is a Hadoop administrator. These are the major divisions, but internally some more divisions are there. Hadoop developers, they will be having more programming model, more programs and less commands related administration. Hadoop administrators, they will be having more commands related administrations and less programming model. But in some of the companies, same person, he himself developing programs and administering all the tools of the Hadoop. Then, why you had to choose Lara to learn Hadoop? The refined faculty and expertise in the Hadoop field. In Lara, not only Hadoop, every software we will be showing right from the scratch like download, install and play around. All the softwares we will be showing right from the beginning, right from the downloading, installation, while installing configuration, after configuration, developing hello world programs. From there, we are keep going through some advanced concepts. Everybody can learn, doesn't require any previous knowledge, doesn't require even expertization in any of the programming language. So even non-technical students also can able to understand all the concepts whichever we are driving in Lara. For every concept, driving with a real use case. This is very, very important. So here, for every concept, we will be explaining through program only. In all, something like a trainings, whatever trainings we are providing to the students, in all the trainings, we are explaining concepts through examples only. Every concept driving with a real use case. With an example, while learning the concept, we will not be forgetting that concept easily. Then the most updated concept with the global corporates. We are incorporating all latest versions whichever required for the global corporates. Hands-on practice in all concepts from every attendee. We will be taking care of whether every attendee practicing the examples or not. Regularly there will be some written tests. Through that written tests we will come to know which attendee is not practicing. Hands-on practice is very much required to become an expert in the particular field. We will be ensuring from every attendee whether he is practicing or not. So 24/7 online help. This is available only for the Hadoop. So for other courses only in the daytime, but for the Hadoop we implemented 24/7 online help. Whenever you are getting any kind of configuration issue while developing programs in your system, in your house, you can just call to us. We will guide you how it can be rectified. If it is unable to rectify over a phone, then we will be interacting to your system through TeamViewer or GoToMeeting, and will take the control of your system. Then we'll rectify whatever mistakes you are doing. Then live project development from every attendee. We will be taking lot of use cases right from the beginning itself. We will be keep developing the same use case in every concept while driving Hadoop. Then finally, placement assistance also we will be providing. So this system is a 64-bit hardware and 64-bit Windows 7 operating system. Let us see how we can install Hadoop in this system. How we can install Hadoop in this system. So inside this system, personal operating system is a Windows 7. Hadoop required a Linux operating system. Hadoop file system is creating on top of the Linux file system. We don't require a separate Linux operating system in our personal computer itself. In our personal Windows 7 itself, we can have a Linux operating system through VM player. Install VM player in our personal operating system. After installing VM player, then you can plug in Linux operating system. We don't require a separate Linux operating system for installing Hadoop. What we can do is first install VM player, then plug in Linux operating system. Inside that Linux operating system, you can install Hadoop. First, let us download VM player. Let us install VM player. So to download VM player, go to vmware.com, downloading VMware. Go to vmware.com. This is the site. So go to downloads. Click on downloads. Under downloads you can see player. You can see player. So click on player. Under downloads, click on player. So you can see VMware player and VMware player plugin for Windows. For all operating systems of Windows, this is the VM player. So click on download. It's just 94 MB. VMware player. We are installing. After installing after downloading VMware player, just install VMware player. Once VMware player is installed, then you can plug in any number of operating systems. You can play around all the operating systems whichever you have plugged in. Go to the downloaded folder. So this is the exe file. Install this exe file. Installation is very simple. Double click on it. So accept the security warnings. VMware player is installed. So go next. Accept the terms and conditions in the license agreement. Go next. By default, it is trying to install in C program files. Better to install in outside operating system drive. Don't try to install inside a C drive. Click on change. I am choosing F drive. Inside F drive, make new folder. Something like a VMware. I am choosing a folder with a name of VMware. Don't give any spaces in this folder. I choose to V in the uppercase, W also in the uppercase. Just to specifying like a two words are there. VM is one word, where is another word. You can go for all lower cases also, but you should not give a space in the middle. The folder name is VMware. Click OK. So this is the location we are choosing. Go next. Let it this checkbox is checking. Go next. This also. Go next. So let it have a icon in the desktop and start the menu. Go next. Continue. So just to provide a confirmation. VMware installation is very simple. VMware player. So click on finish. So VMware has been installed. In the desktop itself you can see one icon, VMware player. This software is ready. Now we need to plug in Linux operating system. Then inside that Linux operating system we need to install Hadoop. Instead of installing separate Linux and then Hadoop, already there is one bundle, there is one distribution which is containing both Linux and also Hadoop. Already one bundle, one distribution is available in the internet. That distribution is containing Linux operating system and also Hadoop. Not only Hadoop installation, whatever basic configuration is required completely already has been done. So we are the beginners. Instead of installing Linux separately, then inside that Linux installing Hadoop, then configuring. We can take straight away a ready-made distribution which is containing Linux, inside that Linux, Hadoop software with full configuration, with a complete configuration. Let us download that bundle, the distribution. That distribution is getting from Cloudera. Go to the cloudera.com. Cloudera company, they are distributing one bundle which contains Linux, inside that Hadoop, not only Hadoop, even with the full configuration available. Go to the cloudera.com. Cloudera company, they are distributing one bundle which is containing a Linux, inside that Hadoop software with full configuration. Hadoop software with full configuration. After going to cloudera.com, go to the downloads. You can see the downloads. Click on downloads. So in this downloads, so try to choose the bundle which is for a single system. You can see Cloudera Quick Start VM. Cloudera Quick Start VM. Cloudera Quick Start VM. This is only for a single mission, only for practicing purpose. We cannot use this in the production. For learning purpose, This is a simple Cloudera distribution on a single system. Click on download and instructions. CDH stands for Cloudera distribution for Hadoop. Cloudera distribution for Hadoop. So we are getting one distribution from the Cloudera to play around with a Hadoop. Cloudera distribution for Hadoop. So click on download. It is a little big file. It will take some considerable amount of time. After clicking on download, check it out the version. We are looking for Cloudera distribution for VMware player. So click on this download and select VMware player. This Cloudera distribution, they are distributing to KVM and VirtualBox and VMware. We required for the VMware. Under version, select VMware. VMware, then click on download. Click on download. Terms and conditions. Accept. Accept the terms and conditions. So while downloading, you will be getting this zipped version. So Cloudera Quick Start to VM 4.4. While downloading, you will be getting one zipped file which is a tar type of the file. Cloudera Quick Start. It is close to 2 GB. It will take some sufficient amount of time to download. Inside this Cloudera distribution, not only Linux operating system, even Hadoop also available. So once Cloudera distribution has been downloaded, just to unzip it. If you have a WinRAR, then it's very easy to unzip. Right click and select extract to. It is extracting zip file into a folder. It is also taking a considerable amount of time. Cloud era distribution. So this is the unzipped bundle. Go inside this unzipped bundle. You need to specify one of this file to the VMware player. Automatically VMware player, it can be selected the suitable file from this folder. Just to supply this folder name to the VMware player, automatically it will be taking one file from this folder. So please observe. This is the downloaded zipped file. Unzipping. This is the unzipped bundle. Go inside. Once again go inside. You are finding 3 files. VM player required one file from these 3. VMware player, automatically it will be picking one file from these 3 after showing this directory. So now open a VM player. Double click on VMware player. So in the desktop there is a icon called VMware player. So in this you can plug in any number of virtual machines. So click on open virtual machine. Click on open virtual machine. Show the unzipped bundle of the cloud era. Show the unzipped folder wherever we have unzipped. Go to Hadoop software. Go to Cloud Era Quick Start VM. This is the unzipped folder. Inside this, again there is one folder. Inside this folder, I showed 3 files. Among these 3 files, VMware player, it is showing only one file. This file only required. Just to select this file. Select this file. Click open. Now, Cloud Era distribution has been plugged inside a VMware player. Cloud Era distribution has been plugged inside a VMware player. This Cloud Era distribution, it is containing a Linux inside that Hadoop. So what is the Linux version? You can see OS Red Hat Enterprise Linux, Linux 6, 64-bit. Operating system also 64-bit. Red Hat Enterprise Linux 6 for 64-bit. If you want to modify any settings for this particular virtual machine, for this particular Red Hat Linux, you can click on this. Edit virtual machine settings. You can specify RAM size or anything. In this system, RAM size is a 8 GB. I am allocating 4 GB for the Linux. Automatically it will be taking half of the. Now, so click on play virtual machine. To start this Linux, you have to click on play virtual machine. To start the Linux, click on play virtual machine. You can see the virtual machine link also here. If one more virtual machine is configured, you will be getting one more link. Click on that, then come to here, play virtual machine. Click on play virtual machine. So click on remind me later. Wherever you are getting this type of pop-up, click on remind me later. This is the Red Hat Linux. This is the desktop. In this Cloudera distribution, not only getting Hadoop, even JDK installation and Eclipse also. In this Linux operating system, we don't require to install JDK and we don't require to install Eclipse. JDK, Eclipse, Hadoop and its configuration all are available. Automatically when browser is opening, I am closing this browser. Now, so click on places, go to home folder. Home folder. So for this Linux operating system, username and password by default both are Cloudera. So whenever username and password is required, enter Cloudera as a username, Cloudera as a password. So home folder, Cloudera user. Username is a Cloudera. So let me create one folder. In the Cloudera user, I am creating one folder. Let us create a folder name as app1. Let us choose folder name as app1. folder name as a app1. Go inside app1. Inside app1, we create one simple file, one simple document. So right click, create a document, go to empty file. Right click, create document and empty file. You can give any file name. I am giving file name as hello.txt. I am giving file name as hello.txt. Open this file and compose some content. Open this file and compose some content. Open with gedit. I am just keeping 3 lines. 3 lines hello to all. Let me close this editor. Let me close this browser also. Let me close this browser also. So this is the desktop. I went to places, home folder, created one directory, app1. Inside app1, created one file, hello.txt. So right click on this, open with gedit. This is the content. Let me close this file. Again close this browser. Close this browser. Now open a terminal. You can see one icon with a name as terminal. It's a command prompt or command window. So click on terminal. Let me increase the font size. This is the terminal. Very similar to command prompt in the Windows environment. So by default, it is opening to the current user. Find out present working directory, PWD. Present working directory. What is the current directory? You can see home and Cloudera. Username is a Cloudera. That is Cloudera user folder. Inside a home Cloudera user folder, present working directory is. By default, terminal is opening for the current user. Home folder of current user. Let's go for list. List. ls is another command. It will be listing all available files and folders. It is listing all available folders and files. So from here, go to app 1, which is the folder we have created. Under our home directory, we created one folder with the name of app 1. We went to app 1. Inside app 1, you can see hello.txt. It is showing one more, that is a backup file. Only one file is available, that is hello.txt. ls is listing. Let us see the content of hello.txt. Let us see the content of hello.txt. To see the content of hello.txt, use cat command. I am using a cat command. Cat space hello.txt. It opened hello.txt. It showed the total content of hello.txt. So this is like a local file system, local directories. Inside a Linux, creating a directory, creating a file, going to the directory, opening that file. We have used very few commands in the Linux. These type of commands are very much required. So you should know some basic commands in the Linux. We just experimented local file system which is created in the Linux. Now let us upload same file into the Hadoop. Let us open the same file from the Hadoop. Initially, let us see Hadoop file system. We didn't install Hadoop, we didn't configure Hadoop. Hadoop is already installed, already configured, already available. Straight away we can make use. Straight away we can make use. Let me clear this console. The command name is HDFS. DFS is an option, distributed file system. HDFS is a command. The command is triggering to browse a distributed file system. HDFS is a command. That command we are triggering to browse distributed file system. -ls. ls is for listing purpose. Just I am giving a forward slash. Forward slash represents the root directory of HDFS. Root directory of HDFS. Hadoop distributed file system. Hadoop distributed file system. Press enter. In the root directory of HDFS, these many directories are there. Just note down only the last column. Names of the directories which are available in the Hadoop root directory. the Hadoop root directory, these are the files available. So please try to observe, Hadoop distributed file system is creating on top of the Linux file system. Hadoop distributed file system is required Linux file system. Hadoop distributed file system cannot be created on top of the Windows file system. That is why Hadoop has to install inside a Linux operating system. Hadoop has to install inside a Linux operating system. In this Cloudera distribution, Linux is there. In Linux only, Hadoop is installed and configured. We are not at all bothering about how we can install Hadoop, how we can configure the Hadoop. We are simply enjoying with the existing setup. Straight away, I am just showing available directory structure in the Hadoop distributed file system. So let me re-trigger same command again to see the content of user folder. So we have permissions to create, remove and copy only into the user folder. There are a lot of folders here, lot of directories. Among them, by default, we have a permissions only in the user folder. Let us browse members of the user folder. Under user folder, multiple users will be. I just wanted to see the folders which are available inside a user. Just to note down only last folder names. Cloudera is a one folder name. History is another folder name. Hive is one folder name. Muji, Scoop 2. These many folders are available under user folder. Every folder is allocated to one user. So Cloudera folder is allocated to one user, history is allocated to one user, Hive is allocated to one user, like this. So we logged in with a Cloudera user name. Let us see the content of the Cloudera folder. The content of the Cloudera folder. The folder name is Cloudera. Let us browse content of the Cloudera. So as of now, no files and no folders available in the Cloudera folder. Cloudera folder is empty. We didn't copy any folders or any files into the Cloudera. Now, Let us take one local file and let us keep inside a Cloudera folder. Whatever local file is there, hello.txt, same that hello.txt, let us copy into the Cloudera folder. How we can copy local file into the HDFS file system? So please observe, under current directory, if we supply just ls, it will be working for local file system. If we supply -ls, then it will be working for HDFS file system. -ls, it will be working for HDFS file system. So in the local directory, hello.txt is there. In the local directory, hello.txt is there. Let us take the hello.txt, let us copy into Cloudera. Cloudera folder in the HDFS. HDFS is a command to interact with the Hadoop. HDFS is a command to interact with the Hadoop. DFS is an option to interact with the file system of the Hadoop. To interact with the file system of the Hadoop. Then go for listing, put command. -put. This command required two inputs, source and destination. Source and destination. Source file hello.txt from the current directory. Hello.txt from the current directory. Then the destination. What is the destination in the HDFS? The destination, you have to choose Cloudera folder. Go for /user/Cloudera. The target directory. /user/Cloudera. Source is current folder hello.txt. Target is Cloudera inside a user. Press enter. Hello.txt. Now check it out whether hello.txt is available in the local file system or not. So we are not moving the file, we are just taking copy of the file and keeping in the Cloudera. Still the same file is available in the local file system. Still the same file is available in the local file system. Now check it out whether same file is available in the Cloudera user or not. So re-trigger the same command. -ls/user/Cloudera. Let us see whether hello.txt is available in the Cloudera folder of Hadoop distributed file system. Earlier we were not getting anything. Now we are getting one file name. There is one row. These are the permissions list. This is the username and password. Sorry, username Then this is the file. The file name is hello.txt. So file is available in the HDFS cluster, HDFS file system. Let us open the file whatever we uploaded into HDFS file system. Let me clear the console. HDFS DFS option -cat. Specify the file. User Cloudera hello.txt. hello.txt. Cloudera folder name, it was wrong. You can see likewise any huge number of files, big volume files, we can upload into the HDFS cluster, that is Hadoop file system. Then you can analyze the same files by using a simple programming model, that is MapReduce. You can upload any number of huge volume of the files into the HDFS cluster. Internally, what is the structure using by HDFS? Lot of internal points are there. I just showed how to interact with the Hadoop file system. We are not bothering about installation, configuration. Straight away we are playing around.